On July 1st, 2025, astronomers logged what should have been the third routine interstellar visitor to our solar system, 3I/Atlas. But within days, reality unraveled. This object, streaking in at over 209,000 kilometers per hour, began decelerating in defiance of gravity, using more energy than all of Earth's nuclear reactors combined. That alone should have been impossible. Then came the pulses, bursts of energy timed to prime numbers, flagged as non-physical by the world's most advanced AI, systems designed to explain the cosmos but left speechless. If 3I/Atlas isn't natural, and even our smartest machines can't decipher it, what exactly has entered our skies? And what happens when we finally see what it wants? The Atlas Survey Telescope in Chile logged the first detection at 0346 UTC on July 1st, 2025. An alert pinged across the Minor Planet Center's network, an object with a hyperbolic orbit, inbound at over 209,000 kilometers per hour. Cataloged as 3I/Atlas, it joined a list with only two other names, Oumuamua in 2017 and 2I/Borisov in 2019. For the astronomers on duty, this was routine, a blip on a screen, coordinates plotted, orbital elements calculated. The trajectory was unmistakable, not bound to the sun, not a long-period comet, but a true interstellar traveler. Survey teams combed through archived images and found faint traces as far back as June 14th, confirming its path was no accident. The orbit's eccentricity, 6.1, left no doubt. This visitor came from beyond the solar system and would never return. Atlas's automated logs flagged the object for follow-up, and within hours, telescopes from Hawaii to the Canary Islands turned to catch it. Data streamed in, brightness, position, color, all as expected for a distant, icy body. For the Discovery team, this was a triumph of modern sky patrol, a rare event, but one that fit the rules. No alarms, no anomalies, just another cosmic wanderer passing through. At least that's how it looked in the first hours after discovery. Within just 8 hours of its initial tracking, 3I/Atlas began to slow down. Not by a trickle, but by a measurable, relentless drop, over 100 meters per second lost in less than a day. No comet, no asteroid, no fragment of interstellar ice had ever shed that much speed, that quickly, without a catastrophic collision. The alert reached Dr. Lina Moretti, lead orbital dynamicist at the European Space Operations Center. Her team ran the numbers 3 times. Each calculation pointed to the same impossible truth. The object's velocity change demanded more than 10 to the 18th joules, an energy budget rivaling what every nuclear reactor on Earth produces in months. There were no jets of gas, no outgassing plumes, no visible debris fields to explain the deceleration. The trajectory bent smoothly, as if guided by an invisible hand. Gravity alone couldn't do it. Solar radiation pressure was 1,000 times too weak. For Dr. Moretti, the equations were clear. To slow a 1-kilometer wide mass from 209,000 kilometers per hour required a force and control no natural process could provide. The data didn't just violate expectations, it broke the rules. If the slowdown was real, something was acting on 3I/Atlas from within or without. Something with a command of energy and precision that defied every known law. The search for a natural explanation ended at a dead end. The only question left was what, if anything, could account for the impossible. At 4:22 a.m., Universal Time Coordinated, 8 hours after the first detection, the data feeds picked up something new. A narrow spike in the radio spectrum, then another, precisely spaced, each lasting less than a second. At first, astronomers blamed interference, but the pulses kept coming, repeating every 37 seconds, then every 41, then 43, each interval a prime number. The pattern was unmistakable. No natural process produces energy bursts timed to prime intervals. The signals were confirmed by the Green Bank Telescope in West Virginia, the LOFAR Array in the Netherlands, and the Atacama Large Millimeter Array in Chile. 3 separate continents, 3 independent confirmations. The pulses weren't random. They swept across the electromagnetic spectrum, radio, microwave, even faint X-rays, always locked to the same prime number rhythm. Some bursts arrived with a split-second delay, as if echoing back from the object's trailing edge. The energy involved was modest, but the regularity was not. Comets vent gas, asteroids tumble, but nothing in the solar system blinks on and off with mathematical precision. Researchers fed the pulse timings into automated classifiers. The algorithms flagged the data as anomalous, then as structured, then as potentially artificial. For the first time, the question shifted from what 3I/Atlas was to whether it was trying to say something. The signals continued, unbroken, as the world's most advanced AI systems prepared to decode them. At 5:13 a.m. UTC, the first AI anomaly logs began to surface. CERN's deep learning array, built to classify everything from supernovae to exoplanets, stalled mid-run. The error wasn't a crash, it was a refusal. The system flagged the 3I/Atlas pulse timings as non-physical, then aborted the inference cycle. Minutes later, a loss spike hit the OpenAI pipeline, outputting a string of zeros and a single word: incoherent. At DeepMind, a senior AI forensics engineer, Dr. Rajiv Singh, watched as 3 independent models, random forest, convolutional net, and a multimodal transformer, cycled through their internal checks, each arriving at a dead end. Not a single classifier could assign the data to any known category. The logs told the story in cold detail. Confidence scores collapsed below threshold. Feature attribution maps lit up on noise, not signal. Saliency overlays focused on the gaps between pulses, as if the absence of information was more meaningful than the data itself. Across the network, anomaly detectors defaulted to manual override. Singh's team reran the pipeline with synthetic data, then with stripped-down features, then with the raw, unfiltered stream. Every time, the models returned the same verdict: unknown, unclassifiable, or, most chilling, non-physical. For the first time, the tools built to reveal the universe's secrets had nothing to offer. The data didn't just break the models, it broke the very idea that the cosmos could be parsed by logic alone. The next step, material analysis, would force scientists to confront the possibility that even human intuition might not be enough. At 5:44 UTC, every telescope caught the same impossible sight. The object fractured, clean, silent, deliberate, splitting into 3 identical pieces. Each fragment drifted outward, settling into a formation so precise it left scientists speechless. An equilateral triangle, each side measuring exactly 1,400 kilometers. No tumbling, no chaos, no scattering debris. Instead, the fragments held their positions, locked in geometric perfection. Then, as if responding to some hidden command, all 3 began pulsing with infrared light. The flashes came in perfect synchrony, each burst lasting 2.7 seconds, each pause matching the others to the millisecond. Instruments confirmed the pulses were not random. Over and over, the pattern repeated, as if the fragments were communicating with each other, or perhaps with something else. In that moment, the universe offered no comfort. The numbers were too clean, the formation too exact. For the first time, scientists watching live realized they were witnessing coordination on a scale no natural process could explain. Within minutes of the split, agency hotlines lit up across 4 continents. NASA's contingency director issued a Priority 1 alert. The European Space Agency, JAXA, and CNSA activated their crisis protocols. An interagency task force assembled in Washington, linking defense analysts, orbital dynamicists, and AI safety engineers by secure line. Policy memos authorized full spectrum monitoring, no data embargo, no blackout. Inside simulation labs, defense modeling teams ran scenario after scenario: collision risk, orbital shifts, electromagnetic pulse, even coordinated signal attacks. Every model returned the same warning: no precedent, no playbook, no reliable forecast. In the war rooms, task force leaders debated response options. Should they attempt contact, prepare for evacuation, or simply watch and record? The only certainty was uncertainty. For the first time, every institution built to defend Earth found itself staring at a problem with no known solution. On July 1st, 2025, 3I/Atlas was logged as our third recorded interstellar visitor, entering on a hyperbolic path at over 209,000 kilometers per hour. Within days, astronomers confirmed a deceleration requiring more energy than all of Earth's nuclear reactors combined. Spectral scans soon revealed engineered materials, and electromagnetic bursts followed a prime number sequence, signals that advanced AI systems failed to classify, with analysis logs reporting repeated non-physical errors. The turning point came when telescopes captured 3I/Atlas splitting into 3 fragments, each maintaining an equilateral triangle and synchronizing energy pulses. In response, NASA, ESA, and global agencies formed a joint task force, but their public reports leave critical data and interpretations classified. To this day, no model, human or artificial, can fully explain 3I/Atlas's trajectory, composition, or signals. The facts remain: an object from beyond our solar system displayed coordinated behavior and intelligence-like signatures that defy current science. As of now, the purpose and origin of 3I/Atlas are unknown.